We are going to talk now about solving linear inequalities. And an inequality is just a statement similar to an equation, but instead of the equal sign, we're going to have one of our inequality symbols, less than, greater than, less than or equal to, or greater than or equal to. So you can see down below in the examples what some of those linear inequalities look like. Okay? Again, they're linear because there's x only in the first power, and it's not being divided or squared or anything like that. Okay. So the goal is the same as when we solve an equation. We're trying to get the variable by itself on one side, and we're going to perform all the same operations. There's just one very important change in the rules, which is if you multiply or divide both sides of an inequality by a negative number, you have to flip the direction of the inequality. So if it was a less than, it becomes a greater than. That's the only extra rule you need to remember. And so these are pretty straightforward. We're going to solve each one of these, put our answers in interval notation. So I'll start by maybe moving the x's to one side. And the numbers to the other. Could have done that all in one step. And then divide. Now I'm dividing by a positive number, so the direction of the inequality does not change. X is greater than 3 would be 3 to infinity in interval notation. So trying number 2, same process. I already have all the x's on this side, so I'll start by subtracting 1 from both sides. Now I see I do have a negative number in front of the x. So when I divide here, the less than or equal to is going to flip to greater than or equal to. And I have negative 4 over negative 8, which would be positive 1/2. So the difference you can see hopefully in the two examples where dividing by a positive does not flip the inequality, but dividing by a negative does. In terms of interval notation, that would be bracket 1/2 to infinity. And so we're going to use that skill a lot. Important to have it. Last but not least in this lesson, we're going to talk about absolute value. We'll talk about what it means and then how to solve things with absolute value. So a lot of times people will say, oh, it just makes everything positive, right? So if I have the absolute value of a negative number, then it's just the positive version. That is true, but that's because absolute value is defined as the distance between 0 and x on a number line. So that's why it's always positive, because distances are always positive. Okay. But knowing that definition can help you, because absolute value, if I'm on a number line and I have a 0, and I know that I need to move, let's say 4 away from 0, well, I can either go to the right or to the left. So whenever we're solving absolute value equations or inequalities, we're always going to have two parts, two different equations or inequalities to solve. And that's because it's a distance. And so I have to take into account going right or going left from 0. So in order to solve an equation, the first thing you need to do is isolate the absolute value on one side. So you need to get everything else over to the other side. So it's just the absolute value of whatever's in here equals this number over here. Okay. If you've got a +5 on the same side, it's not going to work correctly. Okay. It needs to be the distance equals this number. Then you're going to set up your two equations to solve. So the first one will be just drop your absolute values and solve the equation. That will be the going right from 0. But then for the other one, you need to check if you went left, you would have gone to +4 or -4. So you drop the absolute value and make the number negative. That'll take care of, like I said, the right and the left. And then you solve them both. So a couple of really quick examples on that. The first one, there's really nothing to solve because I wanted to just give you this visualization. if I know that the absolute value of x, the distance that this number is from 0 is 5, I'm either going to go 5 this way or 5 that way, right? So I would drop the absolute value for my first solution. I would drop my absolute value and make the other side negative for my second solution. So that's the process in its most basic form. But if you have more than just an x inside the absolute value, the idea remains the same. This thing's value is either 9 or -9 because it's either going right or left. So I have 4x minus 1 equals 9 for my first equation, and 4x minus 1 equals -9 for my second equation. I'm going to solve each one of those. Divide by 4. So 10 over 4 is 5 over 2. That's my first answer. And then add the 1 over and divide by 4. And I get my second solution. And you can double check each one of those. If you were to plug -2 into this, I'd have -8 minus 1, which is -9. Absolute value of -9 is in fact 9. Right? And last but not least, I've got one more example here. This is just to remind you, what was the first step? What did we say we have to do first? You got to get the absolute value by itself first. So I have to move this 3 over before I break this equation into 2 pieces. If you don't do that, then you're going to get at least half of it wrong. One half might be okay, but the other half might be wrong. The other reason I have this example here is I'm hoping you're looking at this and going, wait, that doesn't make sense. I have the absolute value equals a negative number. Absolute value is always positive, or 0, could be 0, but it can't be negative. So as soon as you see this, then you know that this has no solution. So it is true that you could break this up and do 3z plus 10 equals -2, and then flip the other to +2. But whatever answers you get here are not going to check in this original equation. So the best place to find it is at this step here, where you're going to solve and you see that it's equal to a negative. Then no, that's not going to happen. No solution. Now, a little bit more involved are absolute value inequalities. Okay, so absolute value inequalities, for example, I'm going to look here at the first one. The distance away from 0 is less than 5. So if I was looking at a number line, if I know that 5 and -5 are 5 away from 0, and I want the distance to be less than that, I'm going to be looking at all the numbers here and here. Okay. So if it had said greater than that, I would have been looking at numbers out here and out here, right? So you are going to be dealing with 2 inequalities instead of 2 equations this time, okay? So the way we're going to do that is we're still going to set it up in the first 2 steps in the same way. You're going to isolate the absolute value and then make your 2 inequalities. So you just, again, drop the absolute value for the first one, same process. Drop the absolute value, make the number sign negative, okay, that's all the same, and flip the direction of the inequality. So like in this first one, drop the absolute value. There's your first inequality. Drop the absolute value, make the number negative, and flip the direction. So now I have x is less than 5, which would be over here, and x is greater than -5, which would be over here. And you'll notice that we're cutting it off because we're looking for just in this situation, when you started out with a less than, which is what we did, the absolute value was less than a number. My final answer will be the overlap between the 2 solutions you found. So the solutions I found were less than 5, which would go on forever, and greater than -5. So where do those two things overlap? And that would be here, what we had already shaded. So if your original inequality was less than, you're looking for that overlap. If your original inequality was greater than, then you don't have to do the overlap. You just keep everything you found, which I'll show you in the next example. I already have my absolute value isolated, so I'm going to break this into two different inequalities. So just drop the absolute value, drop it, flip the direction, and make the other side negative. Now I'm going to solve. This would be greater than 9/2. -20 here, so x is less than -5. So now, if I were to kind of visualize that on a number line, 9/2, and I want everything greater, and -5, and I want everything less. So you'll notice there isn't even an overlap there. So my answer would include both. It would include this one, and remember our union symbol that we used in the last lesson? This would be my final answer, where it would include both of the inequality intervals that I found. How did I know I was going to include both? Because my original inequality, oopsies, my original inequality was the absolute value is greater than a number. Absolute value greater than a number. Okay. So go ahead and pause your video. You got one more problem to try. Go ahead and pause and give it a go. Okay, let's take a look at what I've done here. Did you remember the first step? You got to get the absolute value by itself first. So I've got to add the 1 over, and now I have the absolute value is less than a number. So the less than cues me in that I'm going to be looking for the overlap when I'm done. So I broke it into the two inequalities, solved the first one. Z is less than 1/2, and I graph that over here. So if this is 1/2, less than 1/2 would be all of these numbers, not including 1/2 because it's not, oh, it is less than or equal to. See what happens when I wasn't paying attention in the first place. But that means I'm going to fill in that dot right there nicely. Okay, so it would be included 1/2 and everything less than. And then on the other side, I'm going to fix my little mistake here. I flip the direction, made the other side negative, subtract, divide, and now I get z is greater than or equal to -21/2, which I have down here. Greater than or equal to would fill in that dot. It would include the 21/2, and it would be everything this way. So where's the overlap? You can clearly see that in between these two numbers would be the overlap, and because these are closed dots, the overlap will include both of those endpoints. So my final solution would be -21/2 to 1/2.